Let's take a look at more theorems that actually give rise to two triangles being similar. This is the side-side-side similarity theorem, which says if the three sides of one triangle are proportional to the three corresponding sides of another triangle, then in fact the triangles are similar. And this actually makes a lot of sense. In fact, this is the definition of what it means to be similar, that the corresponding parts are similar. So this is side-side-side. Let's take a look at a little example where we can apply the side-side-side similarity theorem to an actual question. So here's a figure where we're given various lengths of various sides of two triangles. And the question is, are these two triangles, PQS and QRS, are they similar or not? Well, let's take a look and see about corresponding sides. So let's take a look at the corresponding sides. So let's compare. So we see the 12 and the 12, those are equal here. This is an isosceles triangle. And so here we see the 8 and the 8. So these are going to be the corresponding sides here. So let's compare 12 to 8. So we take 12 over 8. Look at that ratio. And that simplifies to 3 over 2. And so we see that this ratio of this side to that side is equal to 3 over 2. Immediately we see the ratio of this side of this triangle to this side of this triangle is 12 over 8, which is still 3 over 2, so they agree automatically. So the last thing we have to check is the base to the base. Now the base of this triangle is 18. The base of this triangle is 12. And so we have to compare now 18 to 12. So when I compare 18 to 12, I reduce that down, and I see again 3 over 2. So I see, yes, by side-side-side similarity, this side is similar to this side is similar to this side, and this side is similar to this side. So in fact, by side-side-side, we see that these two triangles are in fact similar. They are similar. Great. Okay. Another important theorem is the side-angle-side similarity theorem. By the way, do you notice that some of these have familiar names, like the side-side-side similarity theorem, the side-angle-side similarity theorem, to showing triangles are congruent, right? If we had side, side, side all being congruent to corresponding other triangle, then the two triangles are congruent. Here, if we just sort of slightly weaken the condition, then we get similarity. So you can see parallels with other results. Anyway, side, angle, side similarity. If two sides of one triangle are proportional to two sides of another triangle, and the angle included between them are congruent, then the triangles are similar. So if this side is proportional to this, and this side proportional to this, and they're the same, so that the proportion of these pairs are equal, and this measure of this angle, in fact, is equal, these two angles are congruent, then we can conclude by side, angle, side similarity, these two triangles are similar. So let's take a look at a little example where we can use this fact. So here I'm given two triangles. Do you see both triangles? It may be sort of hard to see. One is this huge triangle, BDA, and the other one is this sort of modest triangle in here, CDE. And I want to know if they're going to be similar or not. Well, first of all, I immediately see that side, angle, side similarity might be a good test to consider because they each share the same angle, D. And so, of course, we know that by the reflexive property, D is congruent to itself. And so, therefore, if I could just show that this side is to this side as this side is to this side, then, in fact, I'd know the triangles are similar by side, angle, side similarity. So let's see if that's really true or not. So let's compare sides. So the big is to the small here. This would be the big is what? Well, this is 15 and this is 3, so the total is 18. So 18 is to the small 3. Well, that works out to be 6. Now, is that the same ratio as big is to small here? Well, big is what? Well, that's 20 plus 4 is 24 is to small 4. and that works out to be 6. Yes, they're the same. So since they're the same, then these guys are actually proportional, and so I see by side, angle, side, these two triangles, the large one and the small one, actually are, in fact, similar.